Hey guys, welcome back to Varnit AI. Today we are diving into the cutting edge world of artificial intelligence with a talk from the renowned Dr. Andrew Ning. Recently, Dr. Ning delivered a captivating presentation at Sequoia, and let me tell you, it's all about agents and he's incredibly bullish on them. In his talk, Dr. Ning dropped some mind-blowing insight. He discussed how GPT 3.5 powered agents can reason up to the level of GPT 4 and shared a plethora of other fascinating tidbits. So stick around as we dissect his talk step by step and explore why it's so crucial. Now, who exactly is Dr. Andrew Ning? Well, he's not your average computer scientist. He's the co-founder of Google Brain, the former chief scientist of Baidu, and a leading mind in artificial intelligence. With an academic background from UC Berkeley, MIT, and Carnegie Mellon, Dr. Ning credentials speak volume. Plus, he's the co-founder of Coursera, where you can dive deep into the computer science and various other topics for free. Impressive, right? But wait, there's more. We are delving into this talk hosted by Sequoia, and if you are not familiar with Sequoia, you are in for a treat. This legendary Silicon Valley venture capital firm boasts a portfolio that's more than just impressive, it's mind-boggling. Get this, their companies represent over 25% of the total value of today's Nasdaq. Yes, you heard that right. From Reddit to Apple, DoorDash to Instagram, Sequoia has backed some of the most iconic tech giants of our time. So buckle up folks, we are about to embark on a journey into the future of AI with Dr. Andrew Ning at Sequoia. But before starting the video, I just want to say that I post videos related to AI every single day. So if there's any YouTube channel out there that can keep you updated on what's going on in the AI world, it's mine. So subscribe and let's get started. First, we will go over the speech and I will add my insight wherever I feel it is appropriate.
So AI agents. Today the way most of us use large language models is like this, with a non-agentic workflow where you type a prompt and generates an answer. And that's a bit like if you ask a person to write an essay on a topic, and I say, please sit down at the keyboard and just type the essay from start to finish without ever using backspace. And despite how hard this is, LMs do it remarkably well. In contrast, with an agentic workflow, this is what it may look like. Have an AI, have an LLM, say, write an essay outline. Do you need to do any web research? If so, let's do that. Then write a first draft, and then read your own first draft and think about what parts need revision. And then revise your draft, and you go on and on. And so this workflow is much more iterative, where you may have the LLM do some thinking, and then revise this article, and then do some more thinking and iterate this.
So a lot of people think agents are just large language models or LLMs, and yeah, technically that's true, but the real power comes from having multiple agents with different roles, background, personas, and tools all working together and iterating on a task. Let me give an example. For writing an essay, you could have one agent whose role is the writer responsible for drafting the initial essay. Then you could have another agent as the reviewer providing feedback and suggestion. You might have separate agent for spell checking, grammar checking, and fact checking. And here's the key, all of these agents wouldn't just take one pass, they would iterate, passing the essay back and forth, with each agent making the improvement based on their specific role. The writer incorporates the reviewer feedback, the spell checker fixes any typos, the fact checker verifies claim, and so on. This iterative process with multiple specialities collaborating is how we as humans often work on complex projects. We plan, we get feedback, we revise, we check details, iterating until we arrive at the best possible solution. An agentic workflow unlocks this powerful capability beyond what any single model could do alone. With the right agent and the right process, you can tackle amazingly complex challenges. So don't just think of agent as language models. They are collaborators and iterators amplifying our problem solving abilities. That's the real power we are unlocking
Through a number of times. And what not many people appreciate is this delivers remarkably better results. I've actually been really surprised myself working these agent workflows, how well they work. I'm going to do one case study. My team analyzed some data using a coding benchmark called the Human Eval benchmark, released by OpenAI a few years ago. But this says coding problems like given the non-empty list of integers, return the sum of all the odd elements or uneven positions. And it turns out the answer is a code snippet like that. So today, a lot of us will use zero-shot prompting, meaning we tell the AI, write the code and have it run on the first pass. Like, who codes like that? No human codes like that. You just type out the code and run it. Maybe you do. I can't do that. So it turns out that if you use GPT 3.5, zero-shot prompting, it gets it 48% right. GPT-4, way better, 67% right. But if you take an agentic workflow and wrap it around GPT 3.5, say, it actually does better than even GPT-4. And if you were to wrap this type of workflow around GPT-4, it also
Let's start by looking at the baseline performance of these models on a well-known benchmark, the human eval benchmark. The zero-shot approach, where we simply ask the model to perform a task without any examples or guidance, yielded a 48% accuracy for the large language model used. GPT-4, the latest and the most advanced model at the time of this recording, achieved a respectable 67% accuracy when used in a zero-shot manner. That's a huge improvement, but we are just getting started. Now let's take a look at what happens when we wrap GPT 3.5, the predecessor of GPT-4, with an agentic workflow. Agentic workflows involves breaking down a task into smaller steps, allowing the model to iterate, reflect, and leverage additional prompting techniques. Surprisingly, even with the older GPT 3.5 model, when combined with techniques like LBBD plus reflection, the accuracy skyrockets to an astonishing 95% or higher on the same benchmark. That's right, by leveraging an agentic workflow, we can surpass the performance of the latest and the greatest model used in zero-shot manner. And it even gets better when we wrap GPT-4 itself with an agentic workflow like the one used in the Meta GPT project. The performance is simply incredible across the board. Agent Coder, another example of agentic workflow, also demonstrates stellar performance, ranking among the top performance on this benchmarks. These results clearly highlight the immense power of agentic workflows when combined with large language models. By breaking down tasks, iterating, and leveraging additional prompting techniques, we can unlock previously unattainable level of performance even with older models.
Does very well. And you notice that GPT 3.5 with an agentic workflow actually outperforms GPT-4. And I think this has and this means that this has significant consequences for I think how we all approach building applications. So agents is a term that's been tossed around a lot. There's a lot of consultant reports talk about agents, the future of AI, blah, blah, blah. I want to be a bit concrete and share with you the broad design patterns I'm seeing in agents. It's a very messy, chaotic space. Tons of research, tons of open source. There's a lot going on, but I try to categorize a bit more concretely what's going on in agents. Reflection is a tool that I think many of us should just use. It just works. To use.
So let's start with the reflection. As the name suggests, reflection is the ability of a large language model to analyze and improve upon its own output. It's like having an internal feedback loop where the model can reflect on its previous response, identifying areas for improvement and generate an enhanced version. The process is surprisingly simple. You prompt the model to reflect on its output, find ways to improve it, and then provide a revised response. This feedback loops allows the model to iteratively refine its output, leading to more accurate and relevant results. It may sound obvious, but this technique has proven to be remarkably effective in enhancing the performance of large language models. By encouraging self-reflection and continuous improvement, you can unlock a next new level of sophistication in your model's response. Now let's move on to tool use. Another game-changing concept is the world of large language models. Tools use refers to the ability to provide external tools or resources to the models, expanding its capabilities beyond its initial training. Imagine being able to give your language model access to custom web scraping tools, stock information, lookup tools, or even complex mathematical libraries. With tool use, you can essentially plug in these external tools and the language model can learn to leverage them on demand. It's like having a virtual assistant that can call upon specialized function or resources when needed. For instance, you could prompt the model to analyze a specific stock ticker symbol and it would automatically utilize the integrated stock lookup tool to retrieve the relevant information. The possibilities are truly endless when it comes to tool use. By providing your language model with a diverse set of tools, you can effectively extend its knowledge and capabilities, allowing it to tackle a wide range of tasks and scenarios. Reflection and tool use are powerful techniques that can unlock the full potential of large language models. By encouraging self-improvement and expanding the model's capability with external tools, you can create intelligent systems that continuously evolve and adapt to meet your specific needs. So whether you're working on research project, building conversational AI assistant, or exploring other cutting edge application, don't hesitate to harness the power of reflection and tool use. These techniques can take your language models to new heights, paving the way for more intelligent, capable, and versatile AI solutions.
I think it's more widely appreciated, but actually works pretty well. I think of these as pretty robust technologies. When I use them, I can, almost always get them to work well. Planning and multi-agent collaboration, I think of it as more emerging. When I use them, sometimes my mind is blown for how well they work. But at least at this moment in time, I don't feel like I can always get them to work reliably. So let me walk through these 4 designs.
So planning in the context of AI refers to giving large language models the ability to think more slowly and methodically, planning out each step of a process or solution. You will likely notice that in my test and demonstration, I often ask the AI to explain its reasoning step by step. This approach encourages the model to plan and think through each stage, typically leading to better and more thoughtful results. Moving on to multi-agent collaboration, which I find incredibly exciting and promising. This cutting-edge approach, pioneered by companies like Anthropic and others, involves having multiple AI agents, potentially powered by different language models, collaborate and share diverse perspectives. But the true power lies not just in having the AI reflect from different personalities or role, but in leveraging the unique strength of various state-of-the-art language models. It's like getting insight from a team of top experts, each offering a distinct viewpoint shaped by their training and capabilities. While there are still changes in getting AI agent to behave precisely as intended, through rigorous testing and refinement, we are seeing phenomenal results that surpass that any single model could achieve alone.
Patterns in a few slides, and if some of you go back and yourself will ask your engineers to use these, I think you get a productivity boost quite quickly. So reflection, here's an example. Let's say I ask a system, please write code for me for a given task. Then we have a coder agent, just an LLM that you prompt to write code to say, def do task, write a function like that. An example of self-reflection would be if you then prompt the LM with something like this. Here's code intended for a task, and just give it back the exact same code that it just generated. And then say, check the code carefully for correctness, sound efficiency, good construction criticism. Just write a prompt like that. It turns out the same LM that you prompted to write the code may be able to spot problems like this bug in line 5, may fix it by blah, blah, blah. And if you now take its own feedback and give it to it and re-prompt it, it may come up with a version 2 of the code that could well work better than the first version. Not guaranteed, but it works, often enough for this to be worth trying for a lot of applications. To foreshadow tool use, if you...
Many of you know, my previous videos have showcased the impressive capabilities of large language models, or LLM for short. We have seen how they can generate code from single prompt, like write the game of snake in Python. The LLM would then provide the entire code in one shot, and I would copy and paste it into my code editor to test it out. However, this process can be a bit tedious, especially when dealing with errors or bugs. That's where automated coding comes into play. Instead of manual copying and pasting the code, we can employ an agent to automate the entire process. This agent can take the code generated by the LLM, run it in a virtual background, and identify any issues or error that arise. If an error occurs, the agent can then feed that error back into the LLM, prompting it to fix or refine the code accordingly. This cycle continues until the code runs smoothly without any error. This automated coding approach offers several benefits. First, it streamlines the coding process, saving time and effort. Second, it reduces the risk of human error as the agent and LLM handle the error detection and correction. Third, it allows for rapid iteration and refinement of code, leading to more robust and efficient solution. However, it's important to note that while automated coding is powerful, it should be used judiciously and with proper insight. It's not a replacement of human expertise and critical thinking, but rather a tool to augment and accelerate the coding process.
Let it run unit tests. If it fails a unit test, then you go, why did you fail the unit test? Have that conversation and maybe to figure out, fail the unit test, so you should try changing something and come up with V3. By the way, for those of you that want to learn more about these technologies, I'm very excited about them. For each of the 4 sections, I have a little recommended reading section at the bottom that, hopefully gives more references. And again, just to foreshadow multi-agent systems, I've described as a single coder agent that you prompt to have it, have this conversation with itself. One natural evolution of this idea is instead of a single coder agent, you can have 2 agents, where one is a coder agent and the second is a critic agent. And these could be the same base LM model, but that you prompt in different ways. Where you say, one, you're expert coder, write code. The other one say you're expert code reviewer, so review this code. And this type of workflow is actually pretty easy to implement. I think it's such a very general purpose technology. For a lot of workflows, this would give you a significant boost in the performance of LMs. The second design pattern is tool use. Many of you will already have seen, LLM-based systems using tools. On the left is a screenshot from Copilot. On the right is something that I kind of extracted from GPT-4. But LLMs today, if you ask it what's the best coffee maker, can do a web search for some problems. LLMs will generate code and run code. And it turns out that there are a lot of different tools that many different people are using for analysis, for gathering information, for taking actions, for personal productivity. It turns out a lot of the early work in tool use turned out to be in the computer vision community, because before large language models, LLMs, they couldn't do anything with images. So the only option was that the LLM generate a function call that could manipulate an image, like generate an image or do object detection or whatever. So if you actually look at literature, it's been interesting how much of the work in tool use seems like it originated from vision, because LLMs were blind to images before, GPT-4V and Lava and so on. So that's tool use.
All right, so let's start by understanding why tools are incredibly important. When we talk about tools in this context, we are essentially referring to the code that gives a large language models its functionality. This code is hard-coded, meaning that the model will always produce the same output we haven't given the same input. This predictability is a key advantage compared to other models that might produce slightly different results each time they are run. Some of the main points are predictability. Predictability of hard-coded code makes these tools incredibly valuable. You can always rely on them to produce the expected output, which is crucial for many applications. Main point is reusability. One of the coolest things about these tools is that we don't have to reinvent the wheel. Programmers have already developed and tested this tool for use in various applications. Whether it's external libraries or API calls, these tools can be seamlessly integrated into large language models, saving time and effort. Third major point is efficiency. By leveraging existing tools, developers can significantly speed up the development process. Instead of writing everything from scratch, that they can focus on building on top of these tools, making the development process more efficient and streamlined. Fourth major point is innovation. The ability to use existing tools opens up the world of possibilities for large language models. They can now tap into a wide range of functionalities without having to rewrite everything, leading to more innovative and powerful applications.
And it expands what an LM can do. And then planning, for those of you that have not yet played a lot with planning algorithms, I feel like a lot of people talk about the ChatGPT moment where you're, wow, never seen anything like this. I think if you've not used planning algorithms, many people will have a kind of a AI agent. Wow, I couldn't imagine an AI agent doing this. I've run live demos where something failed and the AI agent rerouted around the failure. So I've actually had quite a few of those moments where, wow, can't believe my AI system just did that autonomously. But one example that I adapted from a Hugging GPT paper, you say, please generate an image where a girl is reading a book, and the pose is the same as the boy in the image, example.jpg, and please describe the new image with your voice. So give an example like this. Today with AI agents, you can kind of decide, first thing I need to do is determine the pose of the boy. then find the right model, maybe on Hugging Face, to extract the pose. Then next, need to find a post-image model to synthesize a picture of a girl as following the instructions. Then use image to text, and then finally use text to speech. And today we actually have agents that I don't want to say they work reliably. They're kind of finicky. They don't always work, but when it works, it's actually pretty amazing. But with agentic loops, sometimes you can recover from earlier failures as well. So
Yeah, and that's a really important point. Agents are a little bit flinky, but like since you can iterate and the agents can usually recover from their issues, that makes them a lot more powerful. As we continue to evolve agents and get better agentic models, better tooling, better frameworks like Crew AI and AutoGen, all of these kind of flinky aspects of agents are going to start to get reduced tremendously. Imagine a future where agents are not just powerful but also reliable, adapting seamlessly to new challenges, learning from their experience. That's the future we are working towards.
I find myself already using research agents for some of my work where I'll want a piece of research, but I don't feel like Googling myself and spend a long time. I should send to the research agent, come back in a few minutes and see what it's come up with. And it sometimes works, sometimes doesn't, right? But that's already a part of my personal workflow. The final design pattern, multi-agent collaboration. This is one of those funny things, but it works much better than you might think. But on the left is a screenshot from a paper called Chat Dev, which is completely open, which is actually open source. Many of you saw the flashy social media announcement of a Devin. Chat Dev is actually open source. It runs on my laptop, and what Chat Dev does is an example of a multi-agent system where you prompt one LLM to sometimes act like the CEO of a software engineering company, sometimes act like a designer, sometimes act like a product manager, sometimes act like a tester. And this flock of agents that you build by prompting an LLM to tell them, you're now a CEO, you're now a software engineer. They collaborate, have an extended conversation so that if you tell it, please develop a Go Monkey game, they'll actually spend a few minutes writing code, testing it, iterating, and then generate a surprisingly complex programs. Doesn't always work. I've used it. Sometimes it doesn't work. Sometimes it's amazing. But this technology is really getting better. And just one of the design pattern, it turns out that multi-agent debate, where you have different agents, for example, it could be have ChatGPT and Gemini debate each other. That actually results in a better performance as well. So getting multiple simulated AI agents work together has more power.
All right, so he said the important part right here. When you have different agents and each of them are powered by different models, maybe even fine-tuned models, specifically for their task and their role, you get really good performance. And that is exactly what a project like Crew AI, like AutoGen, is made for. Crew AI's AutoGen is designed to optimize performance by leveraging fine-tuned AI models for each agent, ensuring maximum efficiency and effectiveness in every task.
For design pattern as well. So just to summarize, I think these are the patterns I've seen, and I think that if we were to use these patterns, in our work, a lot of us can get a productivity boost quite quickly. And I think that agentic reasoning design patterns are going to be important. This is my last slide. I expect that the set of tasks AI could do will expand dramatically this year because of agentic workflows. And one thing that's actually difficult for people to get used to is when we prompt an LLM, we want a response right away. In fact, a decade ago, when I was having discussions at Google on we call it a big box search, we type in a long prompt. One of the reasons I failed to push successfully for that was because when you do a web search, you want a response back in half a second, right? That's just human nature. We like that instant feedback. But for a lot of the agent workflows, I think we'll need to learn to dedicate a task in AI agent and patiently wait minutes, maybe even hours for a response. But just like I've seen a lot of novice managers delegate something to someone and then check in 5 minutes later, right? And that's not productive. I think we need to, it's really difficult. We need to do that.
All right, so he said the important part right here. When you have different agents and each of them are powered by different models, maybe even fine-tuned models specifically for their task and their role, you get really good performance. And that is exactly what a project like Crew AI, like Autogen, is made for. Crew AI's Autogen is designed to optimize performance by leveraging fine-tuned AI models for each agent, ensuring maximum efficiency and effectiveness in every task.
With some of our AI agents as well. I heard some last. And then one other important trend, fast token generation is important because with these agentic workflows, we're iterating over and over. So the LM is generating tokens for the LM to read. So being able to generate tokens way faster than any human to read is fantastic. And I think that generating more tokens really quickly from even a slightly lower quality LM might give good results compared to slower tokens from a better LM. Maybe it's a little bit controversial because it may let you go around this loop a lot more times, kind of like the results I showed with GPT-3 and an agent architecture on the first slide. And candidly, I'm really looking forward to Claude 4 and GPT-5 and Gemini 2.0 and all these other wonderful models that many people are building. And part of me feels like if you're looking forward to running your thing on GPT-5 zero shot, you know, you may be able to get closer to that level of performance on some applications than you might think with agenting reasoning, but on an early model. I think this is an important trend, and honestly, the path to AGI feels like a journey rather than a destination, but I think this type of agent workflows could help us take a small step forward on this very long journey. Thank you.
Okay guys, so he said a lot of important things. One thing he mentioned is that if you are already anticipating GPT-5, which is like the next generation cutting edge models, they might be available to achieve that. The cost of all these tokens and everything is likely to get sorted as the models become more commoditized. I'm really excited about agent inference speed improvement. I hope you enjoyed Andrew Nick's talk. If you like this video, please consider giving it a like and subscribing, and I will see you in the next one. Thank you so much.